Okay, we'll look at another example of how to solve this on the calculator. So we have a binomial distribution problem, and we'll ignore B in this case because B is not suitable for a binomial model because you don't have replacement, and that means that the probability is going to change from one pick to the next. But in C, we have replacement, so we have a constant probability. So a die is selected at random from the same box, it's color noted, and the die replaced. This experiment is repeated 4 times. Find the probability that a green die is selected fewer than 3 times. And we can model this um, in, let's see, in this way. So this is how we can write it. So green is a random variable, and we read it like this. So G is a binomially distributed variable with the parameters 4 and 0.5. So that's how we read this. And we want to find the probability that green is selected fewer than 3 times. And this bit fewer than 3 times means that there's more than one probability we need to find. We need to find a probability for 0, we need to find a probability for 1, and we need to find a probability for 2. And the best way to visualize this is, well, we can use the probability tool in GeoGebra, where you can see these distributions more clearly. So here we have a binomial distribution with the parameters. I put them in here. So they are 4 and 0.5. And we want to find the probability that G, in our case, is ranging from 0 to 2. Right? So here, this is the probability for G being 0, this is the probability for G being 1, and this is the probability for G being 2. And these are the ones we add together. Now, here in this list, you can see that they are ranged one after another. So it's the sum of these three. So it looks like it's going to be 60 something, but they're not added up right here. We'll look at our calculator and see how we can do this. So on the calculator, we choose statistics. I just want all my keys. So 2. Let's go back. And on this menu, you press distribution, binomial distribution. And I guess in this case, we could use the second option. The first one is binomial probability distribution. And that's going to look very similar to this list here. If you want to add them together, you could choose a cumulative distribution, which adds them up as you go along. So we could see what that looks like and just compare it to the other list. So F2, and again, we have a variable, not a list, and we're going to choose 2 here because that's the upper limit of our cumulative distribution. So that's going to add together the probabilities for 0, 1, and 2. Number of trials is 4, and the probability each time is 0.5. And we execute, and we get a cumulative probability of 0.6875. And that's simply the sum of 0.0625, 0.25, and 0.375. We could have a look at what this would look like if we just selected a regular binomial probability distribution. And that would give us the exact value for 2. So this is equal to the probability for 2. And then you would have to do that for each and every probability, and you could add them together manually.